Let's expand on our customer scenario. The web application is currently housed on a single application server. Two new high-speed servers have been purchased, and the BigIP LTM active standby pair has been placed in front of the three application servers to load balance client connections. The network administrator wants to make certain that the high-speed servers process the bulk of the application traffic and that the old server is used only if and when one of the new servers becomes unavailable, either due to maintenance or a server failure. In getting started with BigIP Part 2 application delivery, we explained the difference between static and dynamic load balancing algorithms and got you started with round robin. But BigIP LTM supports many different load balancing methods to meet many different application delivery needs. For example, least connections is a dynamic load balancing method that favors distributing connections to the pool member that is currently managing the fewest open connections at the time a new connection request is received. The observed method regularly observes the L4 connections to each pool member and then uses that information to create a ratio for load balancing, which is then used to distribute connections among available pool members. We'll focus on the other static load balancing method called ratio and a supporting failure mechanism called priority-based member activation. The round-robin load balancing method works well in many configurations, especially if the servers you load balance to are roughly equal in processing speed and memory. But what if your server capacity is non-homogeneous? Under such circumstances, the static ratio load balancing method can be an effective alternative. The ratio load balancing method comes in two flavors, ratio member and ratio node. In both cases, Local Traffic Manager distributes connections among pool members in a static rotation according to the ratio weights that you define either on the pool member or on the node. Over time, the number of connections that each pool member receives is proportional to the ratio weight assigned, two of which are on servers with approximately 3 times the capacity of the third. We've defined the larger capacity members with a ratio of 3 and the smaller capacity member with a ratio of 1. For every one connection load balanced to 172.16.20.3 port 80, the other two members will receive 3 connections. The distribution pattern starts out looking like round robin, with each member receiving 1 connection. Subsequent connections are distributed according to the weighting factors. In this case, the pool members with the larger capacity receive 2 additional connections each before the pattern repeats itself. If one of the pool members fails, the pattern continues, just with fewer members. While the load balancing method determines the pattern or metrics used to distribute connections across members, priority-based member activation is a complementary feature that allows you to categorize pool members into priority groups so that members in higher priority groups accept traffic before pool members in lower priority groups. You specify a priority group for each member in the pool. Here, we've placed our 2 larger capacity pool members in priority group 5. Our smaller capacity server is in priority group 1. For the priority group activation setting, you specify the minimum threshold number of members that must be available for load balancing. For example, if we set priority group activation to 2 and the number of available pool members in the highest priority group is ever less than 2, the BigIP system will activate all the pool members in the next lower priority group and start load balancing to them as well. If and when the number of pool members in the highest priority group again reaches 2, the pool members in the lower priority group will be taken out of the load balancing rotation. The net effect is, as illustrated here, so long as the 2 pool members in priority group 5 are available, as indicated by a green circle status icon, no traffic will be directed to the member in priority group 1. However, if one or the other member in priority group 5 becomes unavailable, then the BigIP system will activate the member in priority group 1 and begin distributing traffic to it also.